Hello, everyone, and thank you for joining our session today. Today, I'll be talking about the benefits of intradermal vaccination. We'll be covering the following topics below. First, we will look at the basics of intradermal vaccination, followed by an introduction to the MSD vaccination device, the EDAL. And we will follow by introducing our EDAL PCV2 and Mycoplasma pneumonia vaccines and examining their benefits of use in the field that we have demonstrated. So first up, let's talk about intradermal vaccination theory. Target for our vaccination is the epidermis and the dermis. We're aiming to inject the vaccine here because they are very rich in specific immune cells that we need to trigger vaccine efficacy. Normally, to achieve this, we will need to perform a very precise injection using a needle at a 10 to 15 degree angle or a very, very short needle in the field. So this would be very impractical. Injection into the subcutaneous tissue may result in a less than optimal immune response due to the lower portion of immune cells and decreased vascularization compared to the muscle and the epidermis and the dermis. To deliver vaccine into the skin of the pig precisely in the field without restraint, we have several options listed over here. Today, I'll be focusing on liquid jet injection. Liquid jet injection uses a very fine high-pressure jet of liquid to force open the skin and deposit the vaccine at a pre-designated depth. This way, no physical body actually enters the skin of the pig. The skin is forced open by the high-pressure jet of liquid, and after that, the jet will shut off and deposit the vaccine. Other avenues have been explored in the scientific literature, and they are listed over here. For example, one example is the microneedle, and microneedles have been successfully used in human medicine to deliver influenza vaccine in the past. The main issues to be overcome with using microneedles in livestock have been around keeping the microneedle patch on the animal long enough to deliver an adequate volume of compound. Let's look at the differences between a liquid jet and a needle. With the needle, we're usually depositing the vaccine deep in the muscle, and which is highly vascularized. This attracts immune cells traveling through the blood, and then the vaccine forms a bolus which dissipates over time and then may cause abscesses if any impurities are introduced into the injection site. And now with the intradermal vaccination, we do not use a needle, and we produce a finely dispersed deposit of vaccine across a wide area, stimulating many immune cells that are found in the epidermis and the dermis. So what sort of immune cells are found in the skin, and why are they superior? The pig model has been widely recognized as a model for human skin, and so we take a lot of our knowledge around immunology and the function of dermal-dendritic cells from human literature. We see that there are many different subsets of dendritic cells present in high numbers in the epidermis and the dermis. For example, one of the key ones is the Langerhans cell. They function as immune system sentinels. When these cells are exposed to antigen, they cross-present antigen to immune cells and trigger both cell-mediated and humoral responses immediately. They begin to migrate to the local lymph nodes and trigger additional upregulation of the immune system. The dendritic cells are migratory cells, and they continuously travel to the skin-draining lymph nodes to promote tolerance in homeostasis or to initiate adaptive immune responses. Dendritic cells form the key link between the innate immunity and the adaptive immune system. So one can think of them as keys that will help to start up the adaptive immune response, and pigs are often used as immunology models, again, for human medicine due to the similarities. So if we take a look at the human literature, we see that dendritic cells are present in extremely high numbers through the body, especially in the lymph and lymph nodes. And this research shows that after antigen presentation to dermal dendritic cells, these cells immediately commence migration to the lymph nodes and in the lymph fluid in high numbers, triggering a systemic immune response far away from the initial inoculation site. Now we have examined the theory and the target cells that we need to activate with intradermal vaccination. Now let's look at the importance of using the right device to trigger the immune reaction that we want in the skin. And it's important that any intradermal vaccination uses the right amount of pressure and volume to ensure that the antigen is inserted into the skin and not into the subcutaneous fat layer, where the immune response will be much reduced. MSD Animal Health has invested almost 20 years into developing the technology of intradermal vaccination. We have learned through many years of trial and error the techniques of not only delivering antigen into the skin of the pig accurately, but also building the supply chain and equipment needed to ensure that such a high technology device can withstand the daily rigors of use on the farm and having a dedicated logistics support network for these devices. Today, we will be introducing the EDAL 3G Mono and the EDAL 3G Twin. Now, we know that the depth of penetration in the skin is determined by the skin's mechanical properties together with the injection parameters, diameter and velocity of the liquid propelled through the injector nozzle and the formulation itself. Here, we see that there are two modes of operation in the jet injector. We have, first of all, a high pressure mode where the vaccine is pushed in and injected to the correct depth. After this, we transition to a slow filling, low pressure mode where the depth of the vaccine is not increased, but the volume is slowly increased and the volume is now pushed into the right area of skin. So please note that this is only a gel model and we may see differences in depth of deposition in the real pig. This model is only used here to show and demonstrate the depth of vaccination, the different pressure achieved during vaccination. Also, we should note that there are differences between vaccination devices. Not every device will deposit volume and pressure the same way due to differences in design. Now, I have already covered the injection device. Next, I will talk about the vaccines and their benefits that producers can hope to achieve. Here, we see that there are four main areas where intradermal vaccination can bring benefits to producers. I will now discuss each one in more detail. We see, first of all, an increased safety and efficacy compared to intramuscular vaccination, less muscle damage, reduced disease transfer through needles, and potential improvements in animal welfare. First, let's look at the vaccines. The first one is Porcellus PCV-ID. This is a baculovirus express PCV OF2 subunit. With one dose, we're able to achieve protection for 23 weeks, and it's able to reduce viremia, virus load in the lungs and lymphoid tissues, and virus shedding caused by PCV2 infection. Also, there's a reduction of loss of ADG and mortality associated with PCV2 infection, and it is labeled for concurrent use in the EDAL 3G Twin with Porcellus MHyoID1s. The next vaccine is Porcellus MHyoID1s. This is a whole cell concentrate of Mycoplasma hypopneumonia strain 11. With only one dose, we can achieve 22 weeks of protection. It's able to reduce the pulmonary lesions and the decrease in ADG during the finishing period due to infection caused by Mycoplasma hypopneumonia. Again, it is labeled for concurrent use with Porcellus PCV-ID in the EDAL 3G Twin. So if we look at publications, we can see in the scientific literature that for Porcellus PCV-ID, in this comparison between immune responses induced by Porcellus PCV-ID and intramuscular vaccines in 3-week-old piglets, the ID route of PCV2 vaccination of Porcellus PCV-ID was able to induce a more robust and quicker increase in both humoral and cell-mediated immunity compared to the traditional intramuscular route. This field study here evaluated the safety profile of different vaccines administered at weaning, and we showed that in comparison to other IM vaccines, Porcellus PCV-ID was able to induce a lower temperature rise compared to other intramuscular vaccines. Now, pigs will often develop a mild fever post-vaccination. This mild fever may decrease feed consumption and water intake. Due to the lower volume of vaccine needed to induce an equivalent immune response, we are able to maintain the body temperature of the pig at safe levels, ensuring minimal disruption to feeding and activity after vaccination. Let's take a look at Porcellus MHyoID1s. In this study here, Porcellus MHyoID1 was evaluated in field conditions against other intramuscular vaccines. The performance results here showed that intradermal vaccination gave greater protection compared to intramuscular vaccination, especially in regard to morbidity, lung lesions, and pleuritis scores. Putting them both together now, In this study, both Procelis PCV-ID and M-Hyo-ID-1s were evaluated together on their effect on swine production in a field setting. They were compared to intramuscular vaccines. We saw that the intradermally vaccinated pigs had a significantly higher ADG than intramuscularly vaccinated pigs, resulting in a higher average daily gain at slaughter. Here, a trial was conducted in a large integrated farm in Asia. In the treatment group, all needles were removed by administering every treatment through needle-free injectors, both with the MSD IDAL and a non-MSD needle-free injector. So we separated them. On the left shoulder, the IDAL was used to administer PCV2 and Mycoplasma pneumonia vaccines. And on the right shoulder, we used a non-MSD needle-free injector to administer all other treatments and vaccines. So we were able to differentiate the effects of vaccination by the site. In this trial, we saw that the number of broken needles found at slaughter was greatly reduced because no needles were used in the treatment group. However, interestingly, there was an increase in fibrous abscesses in the right shoulder of the pigs. In conclusion, not all needle-free vaccinators are the same. Now, let's take a look at needles next. In swine production, single needles are sometimes used to inject multiple pigs. From the top to the right, from the left to the right, from the top to the bottom, here is a new needle, one after one use, after 12 uses, and after 12 uses with a different photo. And we can see here that multiple injections create small abrasions in the surface of the needle, which are excellent lodging spots for organic matter and can form a possible route for iatrogenic transfer of pathogens from pig to pig through the needle. So in this study here, we investigated the potential of the IDAL to reduce iatrogenic spread of pathogens through needles. So we compared both the IDAL and needles using PRRS virus as an analogy because it has a high transmissibility between pigs. We inoculated cedar pigs with both high and low doses of PRRS before using either a needle or the IDAL to sham vaccinate them at the peak of viremia, followed by immediately sham vaccinating sentinel animals. Now results showed that IM vaccination could transmit PRRS to sentinel animals via the needle, but intradermal vaccination did not transfer PRRS from the cedar to the naive animal. This suggests by using intradermal vaccination, we may improve the biosecurity of the farm by reducing iatrogenic transfer via the needle. It is also important to note here that not all intradermal vaccinators may be able to replicate these results due to differences in the design, pressure, and volume of vaccine administered. So in this study here, we now look at the animal welfare benefits of using ID vaccination. In this study, 3-week-old piglets were evaluated on pain and stress responses during vaccination. And this study here showed that using the ID route of vaccination led to a decreased maximum vocalization and shorter duration of vocalization. Therefore, using the ID route of vaccination led to less animal stress, which may also indirectly improve worker well-being through the decrease of vocalization, and is also less likely to disturb sows and their production in the farrowing house when piglets are being weaned. This takes me to the end of my presentation. I thank you for your attention and look forward to receiving your questions. Thank you.